Hello again, and welcome to this new module on natural language processing. In this lecture, we will have an introduction to NLP. What we will see in this lecture, of course, what NLP is, a brief history of NLP, how we use transformers in NLP, pre-training and fine-tuning. At the end, we will give a small introduction to the meaning of downstream tasks. So, what NLP is? Natural language processing, NLP, is an interdisciplinary field that combines linguistics, computer science, and artificial intelligence to enable computers to interact with and analyze human language. The main objective of NLP is to develop algorithms and models that allow computers to understand, interpret, and generate natural language data on a large scale. So, NLP can be applied in different areas like speech recognition, understanding the context and nuances of languages, and generating human-like responses. Additionally, NLP facilitates extracting valuable information from text and speech data. Where and when NLP started? During the 50s, the Georgetown experiment marked the beginning of NLP with an application of machine translations. Author of the experiment claimed that automatic machine translation will be solved in 3-5 years. During the 60s, Shurdlu and Eliza pioneered early NLP, operating in restricted environments or providing human-like interaction despite minimal knowledge about human emotion. During the 70s, programmers started developing conceptual ontologies to structure real-world information into computer-understandable data, and during the 80s, early 90s, this age marked the birth of symbolic methods focused on rule-based, mostly for parsing, creating the morphologies, understanding the semantics, and giving an increased emphasis on quantitative evaluation that paved the way for modern research. Nevertheless, 90s started seeing achievement in NLP driven mostly by statistical methods, in particular machine translation, with systems like EBMs taking advantage of existing multilingual corpora generated by governmental translations. In the 2000s, with the expansion of Internet, there was a surge in raw language data, leading to more research in unsupervised learning, which, despite being more challenging and often less precise than supervised methods, have been useful to the massive amount of unannotated data available in the Internet, like the entire content of the web. During the modern age, we are in the neural phase, where at the beginning of the 2000s, Joshua Bengio's team successfully used neural network and multi-layer perceptron to enhance language modeling performance, outperforming statistical methods. At the beginning of 2010, we saw a shift toward representation learning and the usage of deep learning methods, driven mostly by work such as word2vec and the ability of these techniques to excel in various language tasks, like language modeling and language parsing. Starting from 2015, NLP has moved away from statistical methods, which require complex feature engineering, and they started using much more neural networks architecture and word embeddings methodology, able to capture the semantic properties of the language in a much more efficient way. Transformer architecture actually eliminated the need for intermediate tasks, such as, for example, part-of-speech tagging that we will see later, and eliminating the need of dependency parsing and word alignment, which were previously crucial for successful accomplishment of NLP tasks. What's the role of transformers in NLP? Transformers have revolutionized natural language processing and even more the field of natural language understanding, having become a fundamental component for modern AI application. The advent of transformer model has initiated a transformation phase in artificial intelligence, crucially supporting language modeling, chatbots, personal assistant, and a myriad of other applications. As we witness a societal shift from physical to digital in areas such as social networking, shopping, media consumption, healthcare, and remote work, these large-scale AI models Handling billions of parameters have become indispensable for navigating the digital landscapes and processing the overwhelming volume of language data. So let's delve a bit more into technical content. What is pre-training? What is fine-tuning? Pre-training refers to the initial phase of training a model from scratch, where its weights are randomly initialized and the model learns without any prior knowledge. Pre-training is usually done on a very large amount of data, and it requires a very large corpus of data, and training can take up to several weeks. Here we see the process and the main issues of pre-training model, where we have large corpus, the need of a large corpus, the need of really expensive computing power and money, and time, weeks of training. Fine-tuning, on the other hand, is the process that follows pre-training, where a pre-trained model undergoes additional training with the task-specific dataset. This method is effective because the pre-trained model already has a foundational knowledge from initial training, which can be applied for the new task. Fine-tuning requires less data and time to achieve good results comparing to training from scratch. Fine-tuning is based on the concept of transfer learning. Pre-trained transfer model, fine-tuned for a variety of NLP tasks, keep leading position in the benchmarks, showcasing their advanced capability in NLP. What are downstream tasks? A downstream task for a foundation model refers to a specific application or a task that uses the pre-trained model as a starting point. These tasks often involve the fine-tuning of the model on a specific dataset. The concept is downstream because it leverages the knowledge gaining from the initial upstream pre-trained phase, which is typically done on a very large-scale general-purpose dataset. Let's summarize what we learned in this lecture. Natural language processing, NLP, is an interdisciplinary field that combines linguistic, computer science, and artificial intelligence to enable computers to interact with and analyze human language. NLP has moved away from statistical methods, which require the complex feature engineering, toward neural network and word embeddings, capturing the semantic property of words in a much more efficient way. Transformers have revolutionized NLP and even more natural language understanding, having become a foundational component of modern AI applications. A downstream task for a foundation model refers to a specific application or task that use the pre-trained model as a starting point. These tasks often involve fine-tuning the model on a specific dataset.